Let's start by introducing Phishlets. Phishlets are configuration files used in EvilJinx to define how traffic is proxied and manipulated between the user and a target website. They specify key elements such as subdomains, filters, and tokens, allowing EvilJinx to intercept and capture authentication data like session cookies or credentials without disrupting the user experience. They enable phishing campaigns to bypass security measures while maintaining the functionality and authentic appearance of the target website. Now, EvilJinx is a tool created by security researcher Kuba Gretzky, designed for advanced phishing attacks. It's a man-in-the-middle attack framework used for phishing login credentials along with session cookies, which allows it to bypass two-factor authentication protection. The present version is fully written in Go as a standalone application, which implements its own HTTP and DNS server, making it extremely easy to set up and use. In this diagram, you're seeing the exact process you would follow to execute a modern MFA phishing campaign using the EvilJinx framework. This process highlights the steps involved in most modern campaigns you see in the news or being reported. Generally, the process would look something similar to this. You would begin by sending a phishing email, obviously designed to look legitimate, to a list of targets. Using social engineering tactics, the email directs the target to click on a link that leads them to the domain you've set up and configured with EvilJinx. Next, you'd secure the domain using Cloudflare. Most use Turnstile as it's available for free. You must do this nowadays or your server will get blacklisted. This adds a layer of defense by masking your infrastructure and providing a valid certificate. Then the phishlet, in the center highlighted in green, ensures this domain is properly configured so EvilJinx can correctly route and proxy all traffic. Once a target clicks the link, they are directed to a fake login page. This is where the phishlet comes into play. The phishlet handles key configurations like replicating the authentication flow and capturing session cookies. At this point, the user is convinced they are interacting with the legitimate site. I mean, it's literally identical and technically is the real site, but it's not. After the target enters their credentials, EvilJinx forwards the login request to the legitimate server, let's say Google's authentication system. This triggers the MFA challenge. Your phishlet manages the session flow at this stage, ensuring it can intercept the next steps. When the target receives the MFA prompt, whether through email, text, or a push notification, they approve it because everything appears authentic. This approval allows you to capture the authentication tokens and session cookies needed to appear as the legit user. Without a properly configured authentication token section in your phishlet, this step would fail, making this configuration critical to the campaign. I will explain how to master this later in the course. At this point, you've captured the username, password, session cookies, and tokens required to bypass MFA, smooth and functional for the target. Now you would open your browser and use a tool like Cookie Editor to inject the captured session cookies. Once the cookies are in place, you navigate to the legitimate site domain, such as accounts.google.com, and gain full access to the target's account without needing to pass MFA again. The session cookies make you indistinguishable from the original user. Throughout this process, you would also use tools like GoPhish to monitor the target's engagement with your phishing campaign. This includes tracking whether they opened the email, clicked the link, or submitted their credentials. These metrics provide insights into the effectiveness of your campaign. This workflow is how professional campaigns are run today, and not that dumb shit you see on YouTube. You will hear people complain a lot, claiming EvilJinx doesn't work, but in reality, they just don't know what the fuck they're doing and need to learn more about how real red teams do it. Basic credential theft is no longer effective against modern targets with MFA and other security layers in place. Every step in this process is designed to overcome those barriers, and every part relies on the proper configuration of your phishlet. That's why this type of education is so important. By learning how to build and refine phishlets in this course, you're gaining the tools needed to execute attacks at the level required to target even the most sophisticated users and systems. This is what separates common basic phishing methods from modern enterprise-level techniques. This course exists to cut through all of that. It was created to give you unfiltered, direct, and practical education that doesn't hold back so you can truly master what others are too scared or unwilling to teach. This course is about phishlets, so let's define what they are and what they do. Phishlets are configuration files written in YAML format that define the behavior and appearance of phishing pages in EvilJinx. They contain all the necessary information to create convincing phishing sites that closely mimic the original target website. Phishlets are small configuration files used to configure EvilJinx for targeting specific websites with the goal of perform phishing attacks. By default, phishlets reside under Phishlets directory in the root directory. Phishlets target specific websites for phishing attacks. Each phishlet is carefully coded to impersonate the look, feel, and technical details of a particular website, down to the host names, URLs, and content. The phishlet defines all the necessary settings from subdomains to URLs mimic the legitimate website. Templates allow customizing certain parameters like subdomains, enabling targeting of websites with personalized host names. Phishlets specify which requests to intercept, content to inject or modify, and how to extract the stolen credentials from the required fields. This process is what the course will focus on. Each phishlet is coded for a specific website. This means that every phishlet is uniquely designed to target and mimic a particular online service or platform. Every phishlet varies in complexity from basic to extremely complicated. Some phishlets may have relatively simple structures designed for straightforward websites or login protocols. Others can be highly intricate, incorporating advanced features to bypass sophisticated security measures on complex web applications. The complexity of a phishlet often correlates with the security measures of the targeted website. More secure websites typically require more complex phishlets to effectively mimic their functionality and appearance. These types of scripts can take days, weeks, or even months to get them to work properly. After initially figuring out all the information required to successfully capture the user's session and cookies, you will then begin debugging the script and correcting any errors that you come in contact with. This consists of constantly writing or deleting code from your script until everything works smoothly. It can take a while depending on the site. You will need to activate EvilJinx developer mode and test the phishlet using localhost. We'll discuss this in more detail later in the course. Most phishing kits available today are largely ineffective, especially when it comes to bypassing multi-factor authentication. These kits struggle with modern security measures and are easily flagged or blocked by browsers and security systems. There was a time when you could generate a phishing link using an ingrok tunnel and successfully trick users, but those days are long gone. If you try this today, you'll be blocked instantly by most modern browsers and security tools. This is a clear indication of how far security measures have evolved, rendering a huge majority of phishing kits obsolete. EvilJinx has had 3 major releases, each update improving on its predecessor being EvilJinx v1, v2, and the latest v3. EvilJinx version 3 was released on May 10, 2023, with both community and pro versions now available. This release offers additions tailored to different operational needs. It features a man-in-the-middle proxy, implementing a custom HTTP client server that intermediates between the target's browser and the legitimate website. The update also includes DNS control, incorporating its own DNS server for enhanced attack infrastructure management. With automated TLS via Let's Encrypt, it ensures seamless SSL-secured phishing. Although known signatures exist for detection, they can be modified or removed, and version 3 signatures are still under analysis by the security community. For more information, please visit the project notes. Now, let's discuss the latest updates to 3.0. TLS certificates from Let's Encrypt now automatically renew, managed by the CertMagic library. Authentication tokens can now be captured not only from cookies, but also from response body and HTTP headers. Phishing pages can be embedded inside iframes. Redirection after successful session capture now uses injected JavaScript instead of the location header. The configuration file format has changed JSON. New features include the always modifier for capturing authentication cookies and a phishlet show command for more detailed information. Phishlet templates have been added, allowing creation of child phishlets with various custom parameters. Another interesting feature is WebSocket proxying has been implemented. You can read the full changelog if needed. Before doing anything, let's do a quick rundown of the key parts of the EvilJinx documentation. We'll go into more detail on each part later in the course. This first part is proxy hosts, in my opinion, the most important part of a phishlet. Proxy hosts define the real website being impersonated. These are the domains and subdomains EvilJinx will handle for proxying the traffic. Next is substitution filters. These are links on the phishing site that match the phish domain, ensuring the user doesn't get redirected to the legitimate site during the session. Then we have auth tokens. This is where the session tokens and cookies used to log in are captured. These are what allow you to hijack a user's session after authentication by injecting them. Following that, we have credentials. This is where usernames and passwords that have been stolen from victims are stored. This is the most straightforward part. Moving on to auth URLs, this is how EvilJinx knows that the session has been captured. By default, it will consider the session as authenticated when all cookies are captured in auth tokens. But there can be an exception when the names of the cookies you need to capture are generated dynamically by the server. In such scenario, you need to use regular expressions to find session cookies or just capture all of them. This section is often tricky to set up correctly, but it's important for ensuring successful user authentication. Login is literally just the login page that users will first see on the phishing site. It replicates the appearance of the real site's login page. The last two are more optional and advanced. JS inject is used to define any JavaScript you want to inject into proxied pages. This can be used to modify forms or manipulate behavior on the fly. Finally, force post allows you to define post arguments to add to an existing post request. In a post request, the client sends data in the request message body, typically to create or update a resource on the server. This can be useful when you need to force specific data, like most commonly, the Remember Me option on a login form to ensure it's always enabled, even if said user left it unchecked. Each of these parts plays a role in customizing your phishlet and making the phishing attack more effective. Throughout the course, we'll break down each of these components and show you how to configure them in a way that gives you more control and flexibility over your scripts.
My name is Kuba Grecki. I am from Gdynia, like this city that we are currently in, and I'm the creator of Evil Jinx, and that's mostly what I work on right now. The talk is gonna be about how much is the fish, which means how much is how much does it cost for the attacker to perform a successful phishing operation, and how to increase these costs on the attacker side. The AI side does not really affect the reverse proxy phishing at all, because the reverse proxy phishing, the idea is mainly to proxy the real website back to the phished user, so it is like a complete mirror copy of it. So AI basically could only influence like the content that maybe is being sent via email, like that you like through spear phishing. It will probably be much easier using ChatGPT to convince other people to click your link and get on to the landing page of your phishing page. It's a great concept, just from the side that you need to attack something to know how to defend against it, and also my talk is also focusing in that way that I show to the defenders how exactly Evil Jinx is able to bypass the protections that they implement, so that they know how to implement these protections in a way that Evil Jinx will not be able to remove. That's mainly like the idea. No, it's for the website developers. Yeah, actually, like Microsoft is actually doing some work when if the web browsers would actually be integrated with the operating system itself, it would be able, like this whole hello, Windows Hello, I think that's what it's called. So if you actually could integrate the browser with the operating system, it would work like a hardware key. So you could like have like a YubiKey, U2F or FIDO kind of solution, then it would generally make phishing impossible. Oh, it's great. Like I've been here since the first time when ZipCon is, and it will be my third time on the stage and first time actually in an official manner as a speaker, because before I just had like lightning talks, like presenting some of my research before. So it's great. Like I recommend it to everyone.